Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Saud Al-Khalifi from team TBA. So this is our project. On the left, we have an MQTT IoT solution for home, smart home. Then that is connected to 3 ISPs. These ISPs have peering points between them, and the cloud is connected to one of these ISPs. In the middle, we have a network for a company, and on the right, we have the user connected remotely to the home. So let's start with the MQTT. In the MQTT, in the home, we have 5 areas, which namely are office, bedroom, security, kitchen, and living room. Each area is publisher to a topic of its name and a subscriber to a topic from the user called away. And then we'll continue with Hassan.
Yes, my name is Hassan Nasser, and I'm gonna explain how the MQTT is connected throughout the networks. These 4 boards connect wirelessly to the home router, which give them the ability to communicate with the broker here. When you open the PT file, all these ports can communicate with the broker and can be clients, and each one of them have a username and password. The same thing happens with the user also. He has an account and connected automatically. Here we have 2 features. The user can publish anything that will control any part of the home network. Like here, it's the humidifier is off. He can publish see what's the topic, and humidifier mode. You can publish using the humidifier mode, on mode, and you could see here it's on, or off mode, it's off. Also, we can control the lights. Like here, we have office light. If he wants to dim it, he could send 1 if it's on, fully on, 2, or 0. Here you can see that this lamp changes the mode, its mode. And also we have the feature of we can see here that the user automatically there is a thermostat and smoke detector, these 2 that automatically publish the temperature and status if there is a fire. Here there no fire, but if we increase the CO2 in the PT back tracer, we could see here that will be fire. Yes, here the smoke detector sent a fire signal before there is no fire, and he could control this by the user, or could be controlled manually. So here, you can see that it's cooling, so the temperature is decreasing. It's fast forward. It's 1 before it was 2. And there is also a feature called away. When the user send an away signal, if it's yes, here the user say to all the home network that he is away, and a security system will be enabled. Like here, the smoke detector, the motion detector here will be enabled, and the siren will goes off, and here there is a movement in the house with the away topic. Also, if we change the light, this light manually, which is called bedroom light, you can see here. Wait, someone changes the mode of the bedroom's light. If it changes manually, and turn it off, and this happens with most of these parts, excluding the fan, because there is no interfacing. We couldn't take the state of the fan, and this is all what is provided, the feature provided with by the MQTT, and we could continue with the networking part with my colleague Farouk.
Okay, Assalamu alaikum. So I will be talking about the network infrastructure for this project. I will cover the backbone internet connections, which is shown in green boxes. So for our backbone, we're using border gateway protocol between each ISP, where the ISP will announce the connected networks to its forwarding ISP to the other ISP, and it will use the EIGRP protocol to redistribute its connected routes through the internal network. So if we go starting from the left, you can go left, Hassan. We have the home network, which is connected to the ISP. So the ISP will redistribute that route and internally using the EIGRP protocol with process 300 until we get to the border router 3. And then router 3 will do a BGP announcement to ISP2 to inform it that it has a route connecting to the home network. And so on and so forth for the other ISPs. So for example, we have on top the cloud service provider, which hosts the MQTT broker server. And in the same way, the ISP in the middle will redistribute the route to that cloud server internally. And then the two border routers will do a BGP announcement. Similarly, we're doing the same for the enterprise network, which is shown down behind the firewall, and to the cellular network on the right, which connects the mobile phones and then NATs the IP address behind the central office server. That's it for the backbone. Now my colleague Yusuf will explain the firewall and the enterprise network shown in the middle.
Okay, as we can see here, we have the company network. Basically, we've used here a firewall because we have a private network and a DMZ which has a public server. For security reasons, we divided the two networks. Basically, the firewall allows a network from the outside only to the public server, only a TCP connection. Even if we ping, it will not allow. And from the private network, it allows only from the inside to the outside. So from the outside, it cannot access to the private network. Let me demonstrate here for you. Basically, if we go to this PC and we want to ping the interface here, it will allow to simulation mode and ping more and more times, so we can see that the packet can go the destination here and it can go back. But for the web server, let's example use this mobile to access the web server. Let's enter the IP. As you can see here, the packet goes through the network. Goes through the firewall. It will allow firewall and it will go back. So just forward. So as you can see here, the connection is established. But if we want to ping the same server, it will not allow. As I said, only TCP connection is allowed. So if we go here, let's try that again. So the packet can go here through the network, but as soon as it reaches the firewall, it will deny it. So as he here says, the packet does not match the criteria of any statement in the access list. The packet is denied and dropped by default. So yeah, this is how the company network works. Thank you for watching. I hope you enjoyed this little demo that we had. Yeah, thanks.